Hi students, now let's learn about the oxidation state of an element. Oxidation state of an element is defined as the charge which an atom appears to have when it is in a combined state. But how do you find the oxidation number? To find the oxidation number of an element, we need to remember certain rules. For example, if you have an element in the elementary state, then its oxidation number is always 0. So like oxidation number of the oxygen in O2 is 0, nitrogen it is 0, elemental state it is 0, iron it is 0, copper it is 0, elemental state, okay, atom in elemental state always the oxidation number is 0. And if you have a monoatomic ion, an ion which is formed from only one atom, the charge on the ion is actually equal to that will be the oxidation state. So like the sodium ion, its oxidation number is +1, O2 negative oxidation number is -2. So the charge on the ion is equal to its oxidation state. The oxidation number of an oxygen, usually it is -2 with some exceptions. So oxygen has always the -2 oxidation state when it is in the combined form actually, with some exceptions. Exception like in the peroxide. In the peroxide we know there is a peroxide linkage like this. So here the oxygen always has a -1 oxidation state rather than -2. Correct? Here also this one has a -1. If it is a hydrogen peroxide, it will be like this. So hydrogen peroxide, hydrogen always has a +1 oxidation state. Okay, always hydrogen always has a +1 oxidation state, except when it is combined with the metals. We know the metals are more reactive metals. Metals are more electropositive elements, and if we have a hydrogen in combined with these metals, with alkali metals or alkaline earth metals, in that case the hydrogen has a -1, because hydrogen is more electronegative element than the alkali metals. So it will take the electrons away. So the oxidation state will be -1 when hydrogen is in combined state with the alkali metals. However, if it is in combination with the p block elements, then its oxidation state will be +1. Okay, so hydrogen you can say always +1 with the exception when it is in the combined form with the metals. With metals it has -1. Oxygen always has -2, exception when it is present in the peroxide. When it has in the peroxides, its oxidation number is -1. And the more electronegative atom than oxygen is fluorine, right? So if you have OF2, oxygen difluoride, in this molecule again, oxygen does not have a -2, we assign a +2 oxidation state for the oxygen, and fluorine has the -1, because more electronegative element will take electrons, so we give the negative sign for that. So oxygen always has a +2, except in peroxide it's -1, and when it combines with the fluorine it is +2. Alkali metals, first group elements, they have the +1 because they lose only one electron, like the sodium it has the +1, lithium +1 always, and group second elements they lose 2 electrons in the valence shell, from the valence shell, so their oxidation state will be +2, right? And to find the oxidation number of an atom in a molecule, right, this last point is very important. The sum of the oxidation numbers of all the atoms in a molecule or ion is equal to the charge, right, is equal to the charge of the molecule or the ion. Let us take some questions and it will be very much clear from the examples. We have certain compounds here. We want to find out the oxidation state of the carbon here in the first example, the green colored atoms here. Okay, so here is the carbon. Suppose I want to know what is the oxidation state of the carbon, and let's suppose that is X. And as I said, that hydrogen has always +1. Okay, hydrogen has always an oxidation state of a +1 except when it is with the alkali metals. With the alkali metals, hydrogen has a -1. Normally, hydrogen has the oxidation state of +1. Okay, so if I want to find the oxidation state of the carbon, so I'll take the oxidation state of the carbon is X plus how many hydrogen atoms are there? 4 into what is the oxidation state of the one hydrogen? That's +1. Okay. What is the charge on the whole molecule? The molecule is neutral, so therefore the charge on the molecule is 0. So total charge is 0. Therefore X will be equal to -4. Okay, this is 4 into 1, that is 4, so it will be -4. So that means in methane the CH4, the carbon has an oxidation state of a -1. Okay, carbon has an oxidation state of -4. So -4. Actually every hydrogen has +1, so this has a +1, this has a +1, this has a +1, so total +4. Charge on the carbon should be -4 because the whole molecule is neutral. Okay, make some sense? Fine. So let's find the oxidation state of the sulfur here now, and let's take that also as X. And what are the elements here? We have a hydrogen, we have 2 hydrogen atoms, right? And we know that the sum of all the oxidation numbers of the atoms is equal to the charge on the molecule. Hydrogen atom is 2, so I'll write down the 2 into what is the oxidation state of hydrogen? That's +1. Always hydrogen is +1, except when the hydrogen reacts with the alkali metals or alkaline earth metals. So hydrogen always has +1. Oxygen always has -2. Right? We have discussed it. That oxygen always -2, hydrogen always +2, with some exceptions. When the oxygen is in the peroxide state, or when it is in the combined state with the fluorine. In fluorine it has a +2, with the fluorine it has +2, oxygen has +2 there, and in peroxide oxygen has -1. While as normally oxygen has -2, hydrogen has +1. So 2 into +1, then plus sulfur, let's say that's X, this is what I want to find, plus 4 oxygen atom is there, and the charge oxidation state of the oxygen is -2. The charge on the whole molecule, the H2SO4 is a neutral molecule, right? So that is 0. Correct? So this will be 2 plus X minus 8. 2 plus X minus 8 equals 0. So the X will be +8 minus 2, this is +6. It will be the +6. Now let's find the oxidation state of the sulfur in the sulfate ion, SO42 negative. And again let me take it X, and oxidation state of the sulfur Bx, plus we have 4 oxygen atoms, and oxidation state of the oxygen always is -2. Okay, will be equal to the charge on the ion. The sulfate ion is not neutral, it has a 2 negative charge, right? So it has a 2 negative, so I'll write down the -2 here. The charge on the ion is -2. Therefore X will be then -2 plus 8. Correct? -2 plus 8, which will be equal to +6. So that means again in the sulfate ion the oxidation state for the sulfur is +6. In H2SO4 they are also the +6. What about this one? HCO3 negative, right? Let's find the oxidation state of the carbon here in this molecule. We have a hydrogen atom here and 1 hydrogen atom, so its oxidation state is +1. Okay, plus X, let that be the oxidation state of the carbon. Oxygen always has a -2, hydrogen always has a +1, so +1 and X, then 3 oxygen atoms there, into the oxidation state of the one oxygen is -2, that will be equal to the charge on the ion. The ion has a negative charge, so it is -1. So this will be 1 plus X minus 6. 1 plus x minus 6 equals minus 1, or x will be equal to minus 1 plus 6 and minus 1, that will be plus 6. Minus 1 plus 6 and then a minus 1, right? So x will be then plus 6 minus 4, it is plus 4. Simple. So oxidation state here in the carbon with the carbon is plus 4. What about the chromium? Okay, in the potassium dichromate ion, in the potassium dichromate molecule, right? Potassium is the first group element. Always the first group element, it has a plus 1 oxidation state, right? Second group has plus 2 because they can lose 2 electrons, correct? So potassium, it belongs to the first group element. It's an alkali metal, so it has the oxidation state of a plus 1. And chromium, there are 2 chromium atoms, and let's suppose the oxidation state of the one chromium is X. Oxygen always has a minus 2. Now let's find the total oxidation state. Okay, we have potassium 2, and the oxidation state of the one potassium is plus 1, plus we have 2 chromium atoms, 2 into, and the oxidation state of the chromium, let's be X. We have 7 oxygen atoms, and the oxidation state of the one oxygen is minus 2. The total charge on the molecule is 0 because the molecule is neutral. Okay, so now very simple. Now the simple maths, 2 plus 2x minus 14 equals 0, correct? So you can say 2x will be plus 14 minus 2, right? So x will be equal to 12 by 2, which is plus 6. So that means the chromium in the potassium dichromate has the oxidation state of plus 6. Hope you got the concept. Thanks for watching the video. Bye for now.